Thank you very much indeed. It's a delight to be here. As we were talking in the break, it's an unusual set of circumstances that's led to all these online things, but it means that me, who is up here in Chicago, can join with you guys. So this is fantastic. So this is a talk, a sort of a version of a talk that I've given, as I was saying to other folks before, a couple of times to people who don't know what a BBC micro is. So on this crowd, I'm not going to spend too much time explaining that because you already know. But I have this slide here where I go from the rather sort of traditional slide to a BBC-ish font. And when I first did this, it was to sort of show the fact that we were moving to a sort of more retro, let's retro this up is kind of the line I used. And it occurred to me only this morning that really I should have spent some time to write a BBC Micro presentation software and do the whole presentation using the emulator. But so unfortunately, this is all you're going to get. So a quick thing or two about who I am. I'm Matt Godbolt. I have been in the US for 10 years, but obviously I'm British. I grew up with the BBC as kind of one of my two default computers. I had a Spectrum actually as my first computer. Boo or cheer. I don't know. I don't want to fan any flames. I really enjoyed the Spectrum, but the BBC Master was the thing that I really cut my teeth on. And really, I learned to program, and I'm a professional programmer now. I learned to program from typing in magazine listings. So, oh, hang on a second. I've got this all out of order. Well, I'm more well known these days for some other website that I do called Compiler Explorer, which you can look up if you're interested in, but that's where I spend the majority of my hobby time, sadly. But why did I choose the Beeb as my sort of main computer? Well, as I say, I'm a professional programmer, and I learned to program by typing in magazine listings such as this. You know, this is the Star Info catalog section, which I'm sure a lot of us used to thumb through when we went to the newsagents and buy our Acorn users. And in fact, myself and Rich Talbot Watkins, who I went to school with, we met on the first day of school, and we've been firm friends ever since. We actually wrote some of these things. So that was kind of my first paid programming job, was getting the £10 and £50 from submitting things to Star Info. And in fact, towards the end of Acorn Users covering of the BBC, Rich and I had written a game, and we were in negotiation about serializing it in, I think, 5 parts. So but unfortunately, the Acorn User folks decided that there was no need to be covering the BBC anymore. It was gone, and they moved fully towards the Archimedes, which was a shame, but it would have been an interesting world if we had been maybe a little bit earlier. So JSBeeb obviously is an emulator that I think most of you have seen or know about, but why on earth did it come about? And I mean, really, the short answer to this is because it's cool, right? I mean, how amazing is it to be able to actually point people at a web browser, at a URL, and relive your childhood? I kind of just wanted to show that it could be done. And I'll be honest with you, this is not the first emulator I've written in JavaScript, which is the language that the web page all run in. I had written a version, I guess there's an interesting story here. Rich and I, mostly Rich, worked on a Sega Master System emulator. So we were discussing in the break about an unreleased game called Blurb that Rich has done, which is itself a version of an Archimedes game, which is itself a version of a Sega Master System game that I had on my Sega Master System growing up. And that we had written an emulator on the Acorn, on the Archimedes for the Sega Master System called Miracle, and it was all in assembly. And Rich now he wrote up a document explaining how the Sega Master System worked, and it is now considered like the go-to document if you want to know how the Master System works, which is crazy, still circulating out there on the internet. And so anyway, many years later on, when we'd first moved over to the US, my wife and family had to go back to the UK for a while and left me home alone. And I decided that I would prove to myself how crappy this web technology was by showing that you couldn't possibly do an emulator in a browser. And it turned out that you can do very well. So I wrote a Sega Master System emulator. And then a few years later, I'm like, well, I don't really care that much about the Sega Master System. There's one game that I love on the Sega Master System, which is Wonder Boy 3, and you should all go and play. But everything else doesn't really mean as much to me as the BBC Micro. So why not turn my attention to the BBC Micro? Sorry, slight off-screen issues going on here. So JSBeeb was born. It lives at bbc.godbolt.org, and it obviously powers bbcmicro.co.uk, which I think is where most of you probably see it and use it. And before I launch into some of the like how it works and how emulators work in general, Kieran suggested that, as many of you probably are already aware of how a lot of this stuff works behind the scenes, that I should actually do like a usability aspect, show some of the usability aspects of JSBeeb. And so I need to get out of full screen mode here, and I'm going to actually try and do some live stuff, which is always scary. So I'm just going to go to bbc.godbolt.org, and hopefully you can all see this still. And I wonder if you could put in the chat, can you hear the beep that it makes? I'm not sure that the sound works on my setup. I don't know that that's important, because I think you all know what a BBC Micro sounds like. But obviously here's JSBeeb. You didn't hear it. Okay, thank you. Never mind. I don't think we need to worry too much about that. And I'm certainly not going to try and play around with Linux audio settings live. That's too scary. So here it is. You've obviously seen the cub monitor and everything, which is kind of a neat, cute thing, but maybe not to everyone's taste. First thing I'd show is that if you really just want to have that full screen immersive experience, if you go into full screen mode, you get kind of a more traditional emulator view where there isn't the outside fluff around, and you just get to see a BBC Micro. So that's kind of a nice thing. I sometimes project this onto my big telly using Chromecast to sort of run on the big screen. There are other options up here. You've probably all used these before, but it's worth mentioning in case you haven't. You can load things directly from the Stairway to Hell archive. So this lets you search randomly. So if you want to pick up Repton, you can go get Repton like this. And it incidentally also updates the URL at the top with the URL that would bring you back to this point. Another thing worth saying is that you can tick an auto boot here, and it also adjusts so that it will just boot into that game. So if you were to actually share this URL with somebody else, they would immediately get Repton, and it would, shift break into the game. Another thing that's kind of useful, if I do, Stardot here, sometimes you want to get the text output, and it's annoying. You can't like select text here and Control-C and Control-V it into something else. But what you can do as a sort of stopgap, and this is Chris's awesome, Scary Beast, Chris, awesome contribution, is if you hit Control-B, it brings up a fake printer. So Control-B is the control code to send everything to the printer. And we actually have a printer, which is just another window. I don't know, let me just start it again. Unfortunately, it pops to the behind. You can see that now the output of whatever I was redirecting to the printer ends up in this regular view, which is just text. So I can copy paste things. I can take the word Repton. I can apparently it should be Lepton or Repton. How funny. Copy that, and then the other side of that is that it's possible for you to paste back into the emulator by pasting into this text box up here. So I'm just going to hit Control-V on my side, and you can see that it typed in Repton. So that's pretty neat. Actually, earlier while I was testing this and running through this sort of presentation, I stole the URL up here and pasted it in, and obviously it pasted the URL in, which is of course no use. And then it reminded me. So I used to work at Google, and I actually had my BBC at the office in Google London. And I think I'm probably the only person who has ever done a full Google search on a BBC computer, because I cobbled together a serial cable and slaved it to a terminal emulator on my main machine, and ran like a curl from that and pasted the results back to the Beeb. And so I actually did get the Google homepage up live. And I mean, certainly maybe other people have done this before, but I'm the only one to have done it, I think, within Google itself. So anyway, that was just a funny little anecdote. So Control-B, yes, I'm looking at my notes over here. So we've got Repton running here. Obviously, full screen is useful if you're going to go and play some things. Some other sort of useful key presses here. If you want to take a screenshot, let me just start running Repton. Oops, wait, I recently have switched keyboard, and my keyboard doesn't actually have any function keys. I have to press chords to get them. So if you see me floundering, it's because of that. So here's everyone's favorite Repton. Oh, and I'm getting refrain of it playing in my ears at extremely loud. So you're probably glad you can't hear it. If you want to screenshot it, you can hit Control End, and now it's paused. And so obviously you can't tell because the music has stopped playing, thankfully for me. And now you can screenshot this without any kind of extra stuff on the top. That's kind of a useful thing. G will restart it. Now, many of you have seen what you get if you press Control Home. So Control Home brings up the debugger. And I think anybody who's written an emulator, the most valuable, the most well-spent time you can spend is to write a decent debugger, because you're going to be spending a whole bunch of time debugging other people's code, other people's games without any source code for it. So it's worth having all of the things available to you. Obviously, you can see we have the system VIA, the user VIA here. I can scroll through the memory here. I'm just using the mouse wheel to go through the memory, but I can type in addresses up here. There's a disassembly view and the registers over on this side. I don't know if you can see my mouse pointer, so I'll start highlighting areas to show you where I mean. So yeah, you can see the scan line someone's just put. That's kind of an interesting feature. So N is the single step to go to next instruction. And as I'm doing it, you may see that there's this white dot moving across the screen, painting as it goes. It's a sort of very cheap and cheerful, cheesy representation of where the CRTC beam is. And it's not 100% accurate. The eagle-eyed among you might see that occasionally, like this red part here has appeared a little bit ahead of where the dot is. But it's a representation of where it is. And as of a recent change we made, you don't see the old picture below. That's a sort of OpenGL optimization. So you can single step through, and that's a useful thing to be able to do. You can do breakpoints. So if I go to like FFEE over here and I click in the old margin, just like an IDE, I've set a breakpoint on FFEE, and then obviously it's not going to do anything with it. Let me escape. Yes, so I hit escape, and we've immediately hit this breakpoint over here. And now I can see that obviously the FFFE, it goes indirect to via 20E of the vector at 20E. The disassembler here has actually looked at where that would go and told me that it'll go to EOA4. And the fact that this is blue means that it's clickable. So I can actually click on it and see where we go. And then I can hit B to go back to where I was before. There's like a stack of disassembly, just like any semi-decent disassembly view. Now, there are some other key presses as well. I can move around inside here. It's probably best for time's sake to point to. There's a wiki that has a bunch of details on some of the key presses which can be useful. But the more interesting, powerful things. Oh, sorry. Yeah, let's see. So you can step in and step out. If I hit N, it will go into that routine. If I hit M, it will step over it. It won't go into it. And then similarly, if I step into this routine, now I'm inside, the Oz routine, I can hit O to come back out again. So I should hit O, and you can see that we've returned back for where that JSR was. And that can be a really useful thing, obviously, if you're trying to say, how old did we get to this point? But more useful than that. And a lot of the more powerful features for debugging they don't have a UI component to them. So now I'm going to hit Control-Shift-J, which brings up the browser's console. I've got it set to be on the right-hand side over here, and you can see all this guff up here. You don't have to worry what this is doing. But now I can actually introspect the code of JSBeeb while it's running, and there are a whole bunch of useful, I think, routines and functions and functionality that you can get access to from this JavaScript console. So the main object I can get access to is the processor. And so I can just hit enter on the processor, and you can see that the debugger for JavaScript has printed out what this processor is. And I can see the stack pointer, the Y, the X, and the A registers, and then there's dozens and dozens of other things. So I don't know if you're the kind of programmer like me, I basically use autocomplete to remind me what the heck's going on. We were talking earlier about remembering things, and I definitely can never remember anything, but I can tell you that if you do processor dot and then debug, you get to see all the things that I've written that are for debug purposes, or the main ones. So JavaScript tends to push you towards like an event model, and I've chosen to represent that also inside of the emulator. So anytime an instruction is run, anytime memory is read from or written to, an event happens, and I can hook into that. And I can optionally, as a result of that event happening, go into the debugger. So for example, this debug read here has a method called add. And what I'm going to do is I'm going to add a handler, a new handler to the list of things that get called every single time a read happens inside the emulator. And what I'm going to do is I'm going to return true if the read address was E00. So I'm basically going to put a memory read breakpoint on E00. Now, one way in JavaScript to do that is to write a function like this. We take an address, we take the byte actually that's going to be read, that has been read, but I don't care about that, and JavaScript lets you get away without writing it. And then I can say return if addr is exactly equal to, 3 equals for stupid JavaScript reasons, E00. So that would be one way of writing this. There's a shortcut convenience way of writing small inline functions, which I'm going to actually use because it's a bit easier for brevity. And that's using this kind of equals less than, which means this is a function that takes an address and returns whether or not address is exactly equal to E00. So I have added one sort of function to this chain. And obviously I can actually write arbitrarily complicated code there. I could actually just return false to not stop, but log things out, or write to the console. Or I could check both the address and the byte that was read. So, or let me restart. Oh, sorry, we've hit our breakpoint on FFEE, which I'll stop. And then I'm going to continue, and I'm going to just reset the Beeb. Oh, of course, nothing ever works the first time. Oh, I've done Control 12. Sorry, excuse me. Please break. There you go. All right. I've managed to unfortunately zoom in, and I'm going to zoom back out again. Oh dear, never do things live. There we go. Okay, now I can continue going. Right. So we still have that breakpoint set on E00. So I'm going to do print whatever is at E00 in BASIC, and indeed we've hit that read point. So that's useful. That would be like if you have an issue in your code where you're like, I don't know how on earth E00 is getting splattered over. Oh, someone just said that you had to reduce the zoom ratio to view what I'm typing. Sorry, I did try my best to make everything fit, but there's a compromise between the screen size and readability and the ability to get all the stuff on screen. So yeah, if you were interested in trying to work out why on earth a particular memory address was being splatted, or if you're debugging a game and you're trying to say, where is it writing to FE00 to program the video chip, you would maybe put a breakpoint of this nature on conditional on the address, maybe on the value that's being read. Similarly, I could have done processor.debug write here and seen where writes were happening. So that was a very powerful and useful facility when I was debugging JSBeeb itself. But oftentimes it's kind of too late by the time you've gotten to this point. Like if for whatever reason we were like saying, I was really interested in working out why we were reading from E00. And that would mean I'd need to know the history of how on earth we got to the point where we read from E00. And that's where the dump trace comes in, because when you are in this kind of mode where you have breakpoints set, JSBeeb is running slower than normal, and it is in fact keeping a ring buffer of the last 256 instructions that it's processed. And so we can get to see what it had been doing up to this point. And so if we look back up this list of things here, these 3 things here are the A, X, and Y register at the point the instruction was run. So you can see here, like on AE7D here, we had A register of OD, but the TXA put the FF into the A register, and so on. And this is the address of the instruction, this is the disassembly of that instruction, and so on. So that's a really, really invaluable way of working out how on earth a memory splat happened. And I think I used this one to find some really interesting bugs that would actually turned out, one thing turned out to be a bug in, I believe, Tom Seddon's master demo, where there was a one cycle window where the ROM bank was not necessarily right during an interrupt handler. And I could obviously, with JSBeeb being... Oh, hello? Sorry?
Yes, me, Sarah Walker.
Oh, it was you, Sarah. Sorry.
Yeah.
I forgot. Sorry. Yes. Sorry, Sarah. Yes. I'm very sorry. Yeah, there was a one cycle window where I think we were just tickling it every time because of the exact setup of how things were organized. So yeah, I think that this allowed me to find what was going on, and we could like look back and go, oh look, this thing has just switched ROM banks, and I don't think it meant to. I don't know, it's very vague in my mind now. So Yeah, and then obviously there's a, we can do a debug instruction here. And so you can add events to the instruction handler. And that obviously one thing to do would be to have like a conditional breakpoint where you're like, okay, if this particular type of, if this address is read from, if an instruction at this address is being read from, I want to stop. That is incidentally how these breakpoints are working. When I click in these margins here, behind the scenes, it is just using the same system to add a breakpoint in the same way, using like a little function. But in my little crib sheet over here, I'm going to steal something. First of all, JavaScript doesn't have good manipulation of strings. So I've got some utility package here that I can pull in. And now I've got like a hex byte and a hex word, which is just convenience. And then I'm going to write the world's most rubbish CPU profiler. And by write, I mean paste in from the notes that I've got over here. So I'm going to take the top 12 bits of every address. So I'm going to ignore 4 bits. This is what the addr bits is for. I'm going to have a histogram, which is going to be an array of 4,096 zeros, one for each 16-byte block of the corresponding address. And then instead of returning true at any time on my debug trace, I'm going to add a little thing that says, given an address, increment the counter at the address shifted down by that addr bit. So we're going to pick the top 12 bits only of the address because I want to like group. This is a poor man's like a sampling profiler. And if I run that and then I hit go over here and then let's go and run. Oh, and I've still got my E00 breakpoint on as well. Let me just turn that off. One thing we can do, processor.debug read.clear, which gets rid of all of those breakpoints. Oh, and I've still got the stupid noises on, which you can't hear, but I'm suffering. I will talk about how to turn those off in a second. We run it a little bit. Oh, that's probably enough for me to get my point across. So I'm just going to deliberately stop it with control. So that's me deliberately pressing the key presses to go into the debugger. But now I can, with another crib sheet here, I'm going to go over that 4,096 array of histograms. I'm going to map it to be something a bit more useful, sort them, and then pick the top 10. And so what we'll find is 8CD0 is apparently where it spent most of its time. I bet you that's why it was idling in BASIC while I was still faffing and talking to you. But this is an interesting way. I mean, I'm just trying to find some ways of showing the other things you can do. I did, for example, use this to get a histogram of the opcodes while I was running Exile and while I was running Elite. And that kind of gave me a hint as to which opcodes were actually worth spending more time looking to optimize or not to make the emulator run faster. Yes. So, and other people who have approached me about their emulators and trying to get them to be cycle perfect, it's relatively straightforward to add a little hook that says, if the program counter is within this range, then print out everything I can possibly find. Print out how many cycles have ever elapsed, print out the A, the X, the Y register, all the things. And then that way you can get them to do the same in their emulator. And then side by side, you can try and work out where you start to deviate from someone else's code. So that's really invaluable. And I think probably those of you writing games might find those things useful. I appreciate that all of the emulators have some level of debugger built into them. This one obviously has the full power of JavaScript if you want to write something really complicated and to say, no, I only want to know the 400th time this happens when the moon is in the ascendant, all that kind of stuff. Okay, I think that's all the things that I had on my list for showing off JSBeeb. So I am going to pop that back over to here, and then my notes here that you'll see. So yeah, full screen, printer, speedy mode. If you hit Control Insert, it takes off this frame lock. And unfortunately, we don't run at the same kind of speed as Scary Beast's Beeb JIT, which is super, super cool. I think you can run it on this laptop. It runs about 8 megahertz is the full speed it'll go, but it's certainly good for getting through like long loading bits and pieces. Debugging, we talked about registers, breakpoints, watch points, and the debug trace, which is called dump trace. Actually, I should really prepend it with debug. Now I've just said to you that debug is the thing that you should be looking for. And yeah, you can go around in the debugger with the various keys that I talked about some of them. The URLs, again, if you bring up that disk panel, you can share a URL that already has some of these in it. But one of the cool things that I quite like is that you can actually load a basic by a URL itself. So over here on GitHub, if I wake this page back up, I have something I found I must have done a while ago for comedy effect. And here's a tiny little basic program which asks you for the nuclear key and then thankfully doesn't launch any missiles at you. What you can do is get the raw, and it's really important you get the raw link here for boring web reasons. And if I grab this, I can now go to bbc.org, query load basic equals that URL. And then I can use the ampersand and say auto run, which means it's going to type run afterwards. So I can hit enter, share that URL with whomever. And if I'm lucky and it works, we get into a basic program, which is kind of a neat way, to, especially on Twitter, to share something silly about, you know, like, hey, here's, you know, those of you who've seen Look Around, you know, the big sort of silly scrolling thing. That's an easy thing to send people a tweet with. And of course, there is actually a Twitter bot now that does something not a million miles from that. So that's kind of a neat thing to be able to do. Auto boot, you can add. If you add the param no seek there, it shuts the disk drive up, and I need to add some UI for that. So if you've hated the sound, I noticed that BBC Micro Co UK does do this already. That's a decent parameter to add. And I also support patching, and this came out from a friend of mine on a mailing list. They mocked up a picture of the Elite screen, and instead of the rating being harmless, it was some profanity, actually, I think. And so I thought I can go one better. I'm rather than like some terrible Photoshoppery, I'm going to share a link which actually boots you into Elite, where that is actually your status. And it turns out, and I'm sure most of you know much more about this than I, that Elite is not straightforward. And so I have a whole blog post here about how I worked out how on earth the strings were stored, which was good fun and resulted in something amusing, which if we have time, I'll show you at the end. But as a result of that, I added this patch facility. So if you can see here in the URL at the top here, I've got this @ and then a comma and then an address and then a patch. What this means is it's going to set a breakpoint at 31AC. And once it hits that point, it will apply the patch, which is itself a comma separated list of address : sequence of hex digits. So if I were to boot up Elite now, if I could remember how to press the right keys, if I wasn't so foolish, drum roll, this is really not worth it. And I should have turned off the disk noise. We get the glory of having the one and only rating of being a monkey, which was amusing to me at the time and was not the profanity that my friend shared. So that's the kind of thing you can do with the patch. Obviously, the breakpoint here is useful because you don't want to patch. You need to know when to apply the patch. And so you find an obvious place. I think I just ran Elite and then stopped it when it was starting to render the old spinny ship and thought, well, that's a good as place as any to make the change. So that's kind of cool. And there are quite a lot more URL parameters. And if you go to the JSBeeb GitHub page, there's a list of them. And I don't think NoSeek is actually on there, amusingly. All right. So this is a big reveal now. Drum roll. As anyone who's been using Slack or Discord or any of the sort of native clients that are really just web pages, there is a facility where you can take a web page and turn it into a native application. Rather confusingly, this facility is called Electron. So I'm glad to announce Electron support in JSBeeb, but it's not what you want, I'm sure. So you can now go and download an exe, a app image, or whatever DMG is for Mac folks. And it's where are we? Over here. I'm going to my JSBeeb. I've got it built somewhere just to show you. There's nothing particularly exciting. But for those of you who need to not have it run as a web page, and it will open the door to more things along the way. All right, JSBeeb, app image. So I'm on Linux, and look, it's a native app. Honest to goodness, there's menus with the load disk stuff, and I can paste, and it actually does do a paste, I think. Maybe it doesn't. I maybe have to fix that. This was all hacked together while I was doing this presentation. I went, hang on a second, I really wanted to do this for a while. So go ahead, knock yourself out. I'd imagine that I'll spend some more time making this a little bit more native-like than it currently is. But Electron support, not as you know it though, in JSBeeb. So in the time that I've got remaining, It's the good kind of electron. So it's not. I'm sorry, OX code. I don't mean to make you sad. I don't know anything about the electron, and I know that somebody has already taken the bones of the JSBeeb code and has turned it into an electron emulator. I'm really glad, and I love the fact that open source lets this happen. So here we are. This is the sort of stage of the talk where I'm going to go into a little bit about how it works behind the scenes. I apologize if this is teaching you things that you already know, but hopefully there's just enough stuff in here that's interesting to keep us going, and I've got to keep an eye on the time. So we all know what x86. Most of the time when I'm talking about assembly, it is x86 assembly. You know what 6502 assembly looks like, so I'm not going to go over this. All those instructions, as we probably know, boil down to sequences of bytes. So load A with 20 is A9 20 in memory, and that's what the CPU reads and it interprets and understands to know what it is it should be doing. They get sort of very complicated, and the pseudocode for load A with paren 70, y is actually reasonably involved, and that's pretty awesome for an 8-bit machine. But we all know that. So again, I don't have to justify to you. So how do you emulate a 6502? It's really just like a CPU would do it. You fetch an instruction, you decode it, and you execute it. And so this is the bones of what any emulator will look like. You have a variable that keeps the various register values, including the program counter here. You have a forever loop, which is going to be like, this is while the machine is still powered up and running. You're going to read from memory, which I'll talk a little bit about in a second, from wherever the program counter is, and you're going to say, well, what is that byte? This is the decode step. And then each of these case statements is going to be essentially the execute for that instruction. So our load A with immediate, we know that the very next byte is the value that we want to load into the accumulator. And really, it's as simple as saying, well, okay, let's put that into the A register, and then now we're done. And this PC++ means it's going to increment the program counter so that we're going to look at the next instruction next time. And so you do load A immediate, you do load A address, and then you kind of put the manuals in your lap and you sit down, write them out, case all the different possible permutations and combinations, which is cool. Oh, I have got highlights for this. I forget what I've got here. Except, I've glossed over pretty much everything. And the wonderful thing about emulators, though, is that you can get an awful lot out with relatively little code. I remember actually, I did a live stream with a friend, some C++ stuff, and I hacked together in Python a 6502 emulator, and it took only about 40 to 50 lines of relatively dense, admittedly, Python code to get the operating system like running enough instructions to show that there was the beginnings of a Beeb there. And I remember one of the first sort of milestones in JSBeeb's life was me just literally dumping 7C00 through the end of 7FFF as ASCII, because that's near enough what the mode 7 screen is. And I could see BBC, 32K and all the good stuff. And that was just a huge like +1 to, I don't really need very much. I just need enough to make the operating system think it's plugged into a Beeb. It's very sort of metaphysical, very deep. But there are some things that we do definitely need to do. So one thing obviously is a processor flags. So some of those instructions need to update the processor flags, like the 0 bit and the negative bit, carry, overflow, and then some of the other sort of slightly more esoteric things that go on. So, now our load A immediate looks a little bit more complicated. We read the value in, and then we say, well, it's 0 if A was anything other than 0. And then because JavaScript doesn't have any types, but I want them to be as typey as possible, this terrible not, which is what that 2 exclamation points is coercing A, which is a value, an integer number, not whether A was true or false. It's dreadful. And these are the kind of things I had to do to make it run fast way back when. I mean, it's been, say, 6 years ago, this was an important thing to do in modern browsers to be able to get them to run fast enough. Nowadays, they're pretty smart. And similarly here, we're negative if the top bit appropriately as well. And then I glossed completely over this memory. I just said, hey, there's a function called readmem that's going to return whatever's at memory addresses. And, as discussed, most of you have this committed to memory, so I don't really need to talk about it. But, our 32K of RAM lives at the bottom. We have 16K of pageable ROM, and then the operating system is at the top. So those don't really go to the operating system ROM chip. They go to various devices on the bus. So our code for reading from memory looks something like this. Now we're going to use this script when they added OpenG array of 32K of uint8s, as in unsigned 8-bit integers. We need to know which ROM we've got paged in. We load the operating system, we load BASIC into ROM 15, and now read mem is just a simple sequence of ifs to make sure where are we in that memory map? Which of these arrays do I need to be looking in? And the one sort of tricky one here is, and I will punt on this one for the purposes of this talk, is that, you know, if it's in one of those 256-byte windows of hardware, then we need to do something cleverer and something special. And that does lead down a very deep rabbit hole. Otherwise, you know, this must be an operating system address in this particular example. And write mem is even simpler, except for the write hardware, because if you write to RAM, you just put it in the RAM, and anything else is ROM, nothing happens. But, you know, again, I've glossed over this read HW and write HW, and there are more than just a 6502 in here. We have the video chips, all of them, that I won't go into because there are at least 3 people that I've seen today who know more than this than I. The sound chip, similarly, and the VIA, the timers. And so, you know, you kind of write those things together. And so putting it together could look something like this. You know, I run a 60th of a second's worth of instructions, you know, 2 megahertz divided by a 60th of a second. And then I paint the screen. And if you were to do that, and that's pretty simple and straightforward, if you were to do that, you end up with something which looks like this. Oh, I did remember to remove the disk drive seek, so it sounds like I need some tea, excuse me. And the eagle-eyed amongst you, who are already rolling their eyes because they knew that I was doing something deliberately bad, you can start to see the problem with that. And that is, we have essentially treated all of these peripherals as totally independent from each other, and we've run them independently, and it's convenient to think of the world that way, but that's not really how it happens. The CPU and the video chip and the timers and the sound chip are running at the same time, cycle by cycle, side by side. And in the way that I've just described the emulator working, that is not what was happening. So you can see here where Elite has its famous split screen mode between the high resolution, low color, and the lower resolution, high color. Try to get that the right way around. That now the interrupt that was switching between modes is not synchronized in any meaningful way. So obviously we can't do that. But how do we fix it? Oh, I described that, that's fine. So now, rather than the CPU running in a vacuum by itself, we want to emulate our instruction, and then we know that 2 cycles of time have passed. So we're going to tell the video chip it should run for 2 cycles and do whatever it would normally do in those 2 cycles. In this instance, it will generate 16 pixels worth of data. And then we tell the timers, hey, you need to run for 2 cycles and do whatever it is. Probably nothing, but you're probably just counting down something. And then maybe setting an interrupt if needs be. So now, unfortunately, all of our instructions are starting to get a little bit more complicated than just they used to be, but that's fine. And if we go, oh, I've done all this, yeah. And now, obviously, it works a treat, and I probably don't have to go through, you know what Elite looks like. So that's cool. I won't go into that. The best thing about writing an emulator is that once you've got a few things working, suddenly tons of things start working. So you want to start loading up your favorite games. And one of my favorite games, and I'm sure yours, is Zalaga. And this is one that Rich DW and I used to play in his bedroom in Horsley, West Horsley. Oh. And so, you know, just bear with me a second. You can't hear the music, but you know how lovely it is. Whoops, but if I press the wrong key on my keyboard, you get to, And then exactly this kind of stuff starts happening. This is sort of motivates writing a somewhat decent debugger. And in fact, if I'm really lucky, this happens about 1 in 3 times that I do this. I'm going to break it. Yes! So if you can see over here, something funky is going on. We're loading AF, X, and then we hit question mark, opcode 87. Well, that's unfortunate. And of course, I'm sure I don't need to tell you what's going on here. Orlando is using the crazy undefined opcodes And so I'm going to take a 5-minute detour to kind of explain a little bit on about how that came about and why they're important and interesting. And this is sort of my other sort of hobby passion, is to know exactly how these CPUs fit together and how they were designed and how they work, and that's carried me through my career. So inside the 6502, we can see that these are the opcodes around that 87 that was a big question mark. We've got store Y, we've got store A, and we've got store X. And you can see that the only difference between these opcodes, this is the representation in binary of those opcodes, is the bottom 2 bits of the opcode. So one might reasonably imagine that the store instruction is basically the same for all of these instructions. It's just that these 2 bits control some aspect of what is being stored. And if we look at the actual picture here of a 6502, you'll see that this top area here, this marked instruction decode, is essentially a big ROM, a big lookup table that determines which parts of the chip are active at what sub-cycle of an instruction. And it just so turns out, if you follow it through, and this is my terrible ASCII art version, so laughter is welcome. I won't be able to see or hear it, but I know that you're chuckling at this, is that inside the decode logic, all the things that happen for a store are looking at these top few bits of the opcode. That 100001 means a store is going to happen. So on the 0th cycle, a store to 0 page. So on the first cycle, we're going to read which 0 page location we want to write to. And then on the next cycle, we're going to write the value of whether it's A, X, or Y. Now that ROM is not totally complete. There was no need to wire all possible permutations and combinations because some of them were just invalid and you were told not to use them. But pragmatically, what's happening is that the S and T here, which I'm using to delineate those bottom 2 bits of the opcode, go into something which checks for not S and not T. And if that is true, the Y register is allowed to write to the bus, which means that whatever store is happening will pick up the Y value. So S and T both being 0 means that the Y register will be output on the bus. A just looks at the T. So if T is true, then A will be splattered onto the bus and therefore written out to memory. And similarly, if S is set, then the X register will be put on the bus. With the opcode 87 that Orlando's using, what do you think is going to happen? There's, unlike in a regular program where you would probably take the time and effort to check that for T that S wasn't set and S that T wasn't set, all that happens is both of those parts of the circuit are turned on at the same time. Oh, excuse me. And that means that both A... Are we good? Yes, good. Both A and X are output to the bus at the same time. Now, as a side effect of the way that NMOS works, the 0 bits win out. So if a 1 bit is being output and a 0 bit is being output, then the 0 bit drains the 1. And so effectively what happens is that A ANDed with X is written out to the memory. And so this is the SAX instruction. Oh, thank you. My wife has just handed me some water. It's very kind of her. Excuse me. Right, so store Y, store A, store X, and then this is store A ANDed with X. And it only occurred to me while Sarah was giving her presentation that this is a really useful thing to do. If you could guarantee that the X was OF for the mask, this could be a useful thing to have in some of those sprite routines. And that may be why Orlando used it. And maybe that's someone who knows more can tell me at the end of this when we're getting there. So we're getting close to time, and I want to make sure that I don't go over to keep us back on track. But as I added more and more games to the list of things, I've got an admission to make. So in, gosh, I must have been 15. Rich TW and I, again in his bedroom, we were trying to fix Alien 8 to work on disk. We had a tape version of it and we wanted it to work on disk. We wanted, for totally legal backup reasons, and I'm so sorry. And those of you who've looked at Alien 8 know that it's got quite a convoluted protection system on it. And Richard and I wanted to remove that so that we could easily put it on disk. And we never were able to. It was so complicated, it was so involved. And I think probably, if he'll correct me if I've got this wrong, the very first emulator that either of us wrote was in BBC Basic, and it was a 6502 emulator, and we were trying to emulate the decrypt code of Alien 8, and we failed spectacularly. And only now, 30 years on later, I understand why and how hard it was. Oh, someone's just told me. Thank you, Sarah. Orlando uses SAX when flipping sprites. Thank you. I'm not smart enough to understand that on the fly, but I trust you completely. Okay, so protection systems, we all know, essentially you encrypt the game code and you put the decryptor immediately abutting the game code so that when you start running the decryptor, it just flows naturally into the game and there's no opportunity to stop it. And obviously, if one was able to modify the decrypt code to just put like an RTS at the end of it, then you could stop it before it started running the game. But numbers of tricks, would be used. Partly, the decrypt key would be things you read off disk. Often it's the decryption code itself. So that means if you mutate the decryption code to stop actually decrypting, then you change the key that decrypts the game. You use hardware timers and registers so that as time's passing, the key is changing, which means if you're breakpointing things or doing any kind of trickery to stop the code, then you're out of luck because the time is still passing. And then you can actually use things like interrupt information, which is what Kevin Edwards uses in this in the worst sort of forms of his protection. I think he deliberately breaks he deliberately increments values inside the interrupt handler that then have an effect on the key, which is bonkers. And then there's this read, modify, write thing where there's an instruction which we're rotating a piece of memory, and that involves a read, a modify, and then a write, and the piece of memory is a piece of hardware. And so there's all these crazy side effects. And that meant that we needed to be even more accurate. So with the instructions that I was showing you before, where effectively the instruction body runs, and then we say, and now time passed, that wasn't good enough anymore, because the cycle within the instruction that the read happens is important, and when the cycle where the write happens is important, because these things have influences on, say, the timers. Visual 6502, I'm sure you all know about. I think Ed is on the line, so yes, the line. Sorry, listen to me. Awesome resource, was super helpful in working out where things happened and at what time. And it allowed me to look at something like this rotate instruction, which has 6 cycles, counting from 0, as all good programmers would do. And on the, so the first thing we do is read the opcode, read the 2 addresses of the address, and then we're going to read the memory. The rotate takes a cycle, and then the store happens. Unfortunately, the 6502 doesn't have a pin that says it doesn't care about talking to memory this cycle. So every cycle, regardless of whether you want to or not, you are reading or writing from memory. And that's usually fine. But not if, for example, that memory is actually a piece of hardware, in which case reading and writing that piece of hardware has side effects. So surprisingly, what happens on this 4th cycle, where we don't want to talk to memory, is that, and again, thanks to Visual 6502, I can see that the write pin has gone high, and the address line is FE48. And what's actually happening is the bus still has the unmodified value of the value that it read in on cycle 3 here. And unless you emulate that, things like Kevin Edwards protection systems don't work. So that was a really fun thing to find. And then, of course, so now this is now, unfortunately, what our instructions start looking like. From that lovely, platonic ideal I started with, we are running 3 cycles here to account for the fact that we've read the instruction byte and then we've read the 2 operand bytes. Then we read the byte and then we say, well, now 1 more cycle has passed. Then we write it back again, even though that should have no normal side effects whatsoever. And then we run the hardware again. And then we do the actual work. And then finally, we write back the modified value. So it's a lot more complicated. And although I'm showing you as if I wrote this out longhand, I didn't. Most of this stuff is actually code generated from the disassembly tables and a few annotations. And there's some optimizations within JSBeeb. Essentially, it's JIT compiling the JavaScript that makes each instruction run as optimally as possible. And then obviously I then eval that in JavaScript to make the actual function. And then behind the scenes, the JavaScript engine, JIT, compiles that to x86 or whatever you're running on, which is kind of a long way from the low level of the 6502, which I actually find quite fun. And of course, I've totally glossed over things like cycle stretching, which was the final piece of the puzzle that allowed, and Richard basically worked this last line out with a very complicated spreadsheet and I think Ed, probably ran a program or two on his real BBC, and we're able to work out exactly the rules about which cycles happen when and what stretches happen. And so as a result of that, I was finally able to decode and run Alienate without any kind of kludgy hacks anywhere in the code. It just kind of works mostly from first principles. And that was an exciting moment. So just as a final point here, I was lucky enough to get in contact with Ian Bell while I was early on in the development of JSBeeb, and he gave me the permission to put Elite into the repository, which is one of the reasons why it's the default image. And then having done that silly hack with the patch to let me overwrite what the harmless with monkey or whatever, I emailed him and said, hey, I've done this blog post, I've reverse engineered how your format worked. And he's like, oh, I've got something for you. And he sent me this, and this is a scan from his dot matrix printout of one of the original pieces of paper that they used, he and Braben used when they were writing that string routine. And it's just lovely. And I think the file name, have I got it here? It's got a file name, and the file name happens to be the file name of the routine, as you can see in the source code of Elite that's out there. So this was a really magical moment for me to sort of see, connect with one of my heroes and hit them send me something pretty awesome. So that's that. So I'm going to finish up with just putting these resources on the screens. I have to say huge thanks to Chris Evans, Rich Watkins, and Kieran for their help on this. And of course, Sarah's emulator was absolutely instrumental in having a sane reference point to start from. And in fact, those who've looked at the JSBeeb source code will see that there are some very close similes in some of the less well-traveled areas of the emulator. Ed, thank you for that, the 6502 stuff, and obviously thanks to Ian Bell, Kevin Edwards, who allowed me to actually write a unit test. So one of the unit tests inside JSBeeb is to be, can we still decode Ultimate Play the Game games? And thanks obviously to the Stardot folks. So with that, I think I'm about on time. And if there is any flexibility in the schedule, I'd be delighted to take questions. Otherwise, I will hand back to Arcadian and Co.
Thanks, Matt.
All right, and I would be interested in any feedback on the native thing. It's a new thing for me, and it's actually a terrible scourge in our life that we are now sort of in the full inception of running native apps that themselves are embedding entire websites that then JIT compile from some dreadful language into x86 to then show you like essentially a chat program. It's dreadful, but I'm contributing to it, but it seemed like a fun thing to do. So thank you all.
I've got a quote on that. When you were doing this, you say you started this sort of 7 or 8 years ago. How much faster now, and how much have you sort of soaked up that fastness with new features? Has it become over those sort of 6 years?
It's stayed remarkably consistent. I have got some benchmarks that I run from time to time, and they've stayed pretty on the ball. I've mostly taken out the sort of browser special tricks that I used to do. So I used to detect which browser you were on, and I knew that Firefox, for example, was much better to use this way to dispatch. Like obviously I've completely glossed over a lot of the details here. That's the fun part. So if you just write a switch statement with 256 entries in it, Firefox was great. Chrome deopted the whole thing. It's like, hey, this is just too big. It's not worth JIT compiling this. I'm like, no, it really is worth JIT compiling this. And so it ran at terrible speed. So there was a whole bunch of hacks that detected what was going on. And I filed a number of bugs with both Chrome and Firefox. Excuse me. And they've fixed pretty much everything now. So I've taken out most of the special Casey hacks, and I actually have some great Firefox swag they sent me for finding all these performance issues. It's really cool. So I haven't had to spend too much time optimizing it. I will be honest, adding the debug logging stuff, or sorry, rather, taking that out, having a special version of the main loop that said, like, if none of the breakpoints are set, and if the no one's watching anything and there's no things, then call the version of the main loop that doesn't even have the checks in it. Now, in theory, JIT compilers should be able to work that out for themselves, but it's useful to give it a big hint. That made a big difference in terms of the performance. But realistically speaking, most of the things that I've added in haven't added any a major disadvantage.
And how much headroom have you got left? You said if you sort of run it at full tilt, what do you get up to? About 8, did you say?
Yes. So there's not a giant amount of headroom. You know, like I'm basically twice as fast as I would need to be. A lot of the time is actually spent in the video emulation. The CPU is one thing, but like getting the video right is tough. I think if we were to do it again, and I think, you know, again, Gary Beast is around as well. There could be some clever way of, I don't know, serializing to another thread. Now we can do threads in JavaScript, which is of course frightening. Using more of the OpenGL acceleration to do some of the trickery that we're doing in plain software. I mean, I have got one thing that uses OpenGL to turn from like a Java native, a convenient for BBC Java native, JavaScript native thing into the actual pixels you see on the screen. So it's not that much headroom. I think that's a fair point.
Cool. I've been trying to get, I'm doing the Blitz thing, and I'm trying to get that running parallel with the rest of the graphics. And that's got 3 processors going at 8 megahertz, and I can just about squeeze it into BM. I'm wondering whether I might have a go at JSBeeb as another option.
That would be fun. I mean, you might find that it's okay depending on how complicated the Blitzers things are. And
they're not too bad actually, but you've got to have the CPU socket updating the hardware every tick, because the Blitter is probably going to poke a pixel at the screen in that tick. It's probably going to tickle some hardware every tick.
So of course, so you actually doing like the Amiga style thing where you get the Blitter to poke the hardware?
Yeah.
Oh man, that's amazing and awesome, but also terrifying for emulator writers, because that's like, oh sugar.
No, it's dead easy in the FPGA, but actually getting it to work in an emulator at speed, it's like, oh, I shouldn't have done this.
I know, that's brilliant. I mean, and especially like with things like Beeb JIT and stuff, or even just like even just using a compiled language. I mean, for God's sake, this is a supercomputer by anyone's stretch of the imagination over here. That is, sorry, I'm pointing my laptop. You know, we should have plenty of time. It's ludicrous to even do it in JavaScript and then hope that somehow the 28 layers between you and the microcode of the computer, the CPU that you're running on actually doing the work is fast enough. That's an interesting one. So one thing I have experimented with, and the reason I did the live stream with a pal was we were thinking and this is sort of links us back to Sarah's talk about the little invader patterns, the waveform, the enemy behavior is using coroutines, which is, you know, Knuth's name for the posh routines that call each other and one returns from one thing to the other and all that kind of nonsense. So in that world, you could actually write the almost boring straight line code of the CPU that's like, okay, tick once, do the other thing, and then the CPU is not special. At the moment, the CPU is special because it's the source of time as we move forward. Like, you know, I'm the CPU, I did one instruction, therefore I tell everyone else they should move one instruction forward, and that makes it very awkward. But if you essentially just have a yield, exactly like Sarah was doing with the JSR, to like run the baddies for a bit, and then when it returns back, some time has passed and everyone else has had their go, then it becomes an easier way to write lots of little snippets of code, and then and maybe and the reason I brought this up is that the C++ committee have voted in coroutines as like a thing that's going to happen in C++ 20, so there may be some compiler support in there in that world, so maybe that'll help. But I mean, ultimately you just got to do the work, right? And if you're programming poking the video chip on every other frame or every other cycle, then you have to simulate it that way. With the sound chip, I get away with like a cheat where effectively I keep a tab of the last time you poked any of the registers for the sound chip, and then I don't really run it until either I need some audio, in which case I go back in time and go, well, what were the settings at this point? Okay, play it forward. Or you change one of them, in which case it goes, okay, this much time's passed, fill in with the old settings, and now remember this new part is the thing. So you get the benefit of like a sort of a big chunk of work to do. I'm sure all the other emulators do that too. Any other questions out there?
What are your I'm interested. What are your plans for JSBeeb next? How can you? I mean, you can make it faster, but what? Yeah.
Good question. I mean, in preparing for this, it was kind of clear that there's not really any UI for a lot of the things that I use, like all that stuff I showed with the JavaScript panel. There's a world in which some of those things, or at least, are exposed through the UI, so you can do some debugging and whatever. I'd kind of like to be able to put, and I realized my Miracle, the Sega Master System emulator, has this feature, and I can't believe I didn't bring it across. You could tag addresses, and like, where the address was in the disassembly view, you could click and then you could type a name, and that way it would be replaced with that name. And I know that other emulators support that kind of thing, and I think you can even export that. So loading that in would be a cool thing to be able to do. I mean, I'm not blessed with an enormous amount of time. I know we all talk about this and none of us have. My other hobby project keeps me busy all the time, but I would like to get back to it. I think I'd like to actually write something that ran on it, as opposed to adding things to the emulator itself. But certainly, maybe fleshing out a little bit more of the app version would be worthwhile. Surfacing some of the debug features that are already in there would be cool. NULA support would be nice. I'd like to do that, if only just to learn what cool things can be done with the NULA. I don't think I've ever said it out loud before. How do you say that? Is it NULA or NULA? Who do? Someone chime in and tell me how foolish I sound.
Do you think it could be used to? Do you think you could simulate any other hardware on it at all, like BBC hardware or?
There's no reason why not, and especially the more esoteric the hardware, the less with the exception of blitter chips, the more esoteric the hardware, the less likely you need to be really cycle accurate. So certainly, it does work with you can have a tube processor, and I can fire up another one. And I could add an ARM or whatever on that, but I would involve writing one, which is I'm too lazy to do. So I think other hardware could be supported, and I've got a long outstanding. There's a chap who uses BBC, or had used maybe BBC Micro with people that have learning disabilities or physical disabilities, and so he had all of the peripherals for pressing the buttons and things. And so I started putting in things to allow them to rerun those things, because that's an awesome thing to be able to do. Is this is what we did 30 years ago for everyone, right? Regardless of ability. So that's another thing that I probably do, a bunch of switch support and touchscreen support.
I was thinking of like AMX mouse or something. Or
yeah, I think
I mentioned that to you once. I was the person. Yeah.
Yes.
Because I've got an iPad. You see, I know iPads, blah blah. But yeah, I was thinking, oh man, this could be possible here on an iPad.
The biggest issue with those things is the disconnect between the way that the AMX mouse works. Is it's delta based from where it last was. And obviously a touchscreen is just, it teleports around, and trying to synchronize where as the hardware, pretending to be the hardware, you can't tell where it is. That doesn't, the mouse doesn't know where it is. It just knows how much it moved since the last time. So trying to square the circle of that. And if anyone's got some smart ideas about how one could do that, otherwise you'll be forever drawing and the mouse pointer will be away from where your finger is. And that would be irritating.
I see. Yeah.
Yeah, there's no sort of centering operation or scaling even to say okay, if I move my finger 1 inch across here, it moves 300 pixels in iPad space, and how far should that be? That one's probably easier to do, actually. You could probably work out what that is.
Yeah, or even a Music 5000.
Right. Someone's saying the VMware is just as bad over there.
Write
the electron wrong by adding the electron as another machine variant. We could potentially that could happen, but I'm no expert in electron stuff. The electron was just something a friend of mine had. We'd go around to their house and she would play Repton. That was what we did on the electron.
Where are you with joysticks now, Matt?
Oh, good question. At one stage, somebody submitted a whole bunch of patches to make it work with like an Xbox controller, and I have no reason to think that that's broken. But I think that's more like pressing the keys with an Xbox controller than it is supporting like an analog, the good old fashioned ice cream cone type joystick. So yeah, I haven't really thought about that, but that would be a good one to do. Although I don't know what you would emulate it with on this side. Maybe the mouse.
Yeah. Well, paddle as well. Work with a mouse.
Oh yeah, that's true. The paddles probably work better than like a touchscreen type thing. And obviously, people ask for like it working on an iPad in any way that's not totally dreadful. That involves actually writing a virtual keyboard, unfortunately, because a lot of those things have got a keyboard, but I'm trapping the key down and key up events, and they're mapping to physical hardware. So it's not like I can accept, various chord presses that you press on that, unless I know that you press shift and then you press break, and the shift is still down when you press break. Most of the keyboard interfaces I've seen don't work that way. They're like, you press the A key. I'm like, yeah, I know, but are you still holding it down?
It's an amazing thing, JSBeeb, by the way.
Oh, thank you. As I say, I always feel this is a story of all my hobby projects. Is they're always, I feel very fraudulent because they're always built on someone else's clever idea.
Well, I always say, thank God we got people like you.
Thank you very much. That's very sweet.
For the mouse thing, you could add a rectangle on screen and scale the movement within that.
Yeah, the scaling is one thing. It's like the centering aspect of it. Obviously the mouse pointer is something that the software knows where it is. Only the software, and it's individual for each piece of software. Like you fire up AMX Paint or whatever, and the mouse pointer is in the center of the screen. And you have to know that, so that when somebody presses over here, you can't see where I'm pressing, presses over here, that actually you need to turn that into a jump of 50 pixels to the right. Yeah. Otherwise, it's like, okay, well, you started there. Now, as you drag it around, it's like, well, I'm moving from the center. And of course, you can probably account for that in some way. But I'm not clever enough to think of a way of doing it.
For a mouse, you could probably hack the 2 or 3 programs that use it on the Beeb side, so you know where it is.
That's true. That's very true. Have you seen the I forget his name. There's a rather bonkers chap who has done like a 3D versions of NES games, including like Zelda and stuff, and he has this automatic process for determining where the player character is by like saving emulator state, running forward and backwards and seeing which memory values work, and then it's like, well, that must be where the character is, and it's like totally automated. It's crazy. I guess loading and saving would be a useful thing to be able to do. That's one thing I keep punting on, because web browsers in general don't like you storing giant gobs of information, and so like storing for a master, all the 128K of memory as a string, as it would have to be, is not very enticing. Although 128K is nothing these days, is it?
So it doesn't sound a very big job now.
I know. Does anyone else who works like in compile programs now, did you shudder inside when you do? I just need a buffer to store some like, I don't know, it's a URL. And you do char buff 32768, and you're like, I just blew an entire BBC micro for just a piece of temporary text that's probably not going to be longer than like 12 bytes. What is wrong with me? What has happened to my career? How do we get here?
Are you adding any more 6502 tool chains to compiler?
I haven't got any plans at the moment, but that's another thing. So you can go and actually see. I mean, tool chains is strong really for Compiler Explorer for 6502, because like it's like, honestly, there's the worst 8-bit processor to try and fit C into. It's a terrible idea. Like the Z80 at least has enough registers to be worthwhile, but people wanted it, and Jason Turner has, if you've not seen his C++ talk on rich code for tiny computers, that's worth an hour of your time, where he builds like full on all the bells and whistles C++ 17 feature-based bat and ball game for the Commodore 64 and runs it live on stage, which is just wonderful. and it uses a terrible trick. It just takes x86 and transcodes it for the dozens of opcodes that actually get emitted for the kind of code he's writing. And I think it's a great pragmatic way of achieving a neat goal. We have that on Compiler Explorer. There's also BeebAsm, beebasm.godbolt.org, which shows like me trying to square that circle in a different way again, where it's essentially takes Rich DW's BeebAsm, sorry, Beeb IDE, beebide.godbolt.org, takes Rich's BeebAsm, it compiles it from C to WebAssembly, which is like an interpreted version of the environment and embeds it, and you've got an editor on the left-hand side that you can type in your Beebasm, and as you're typing, it's compiling it in JavaScript on your machine, and then it injects it into an older version of JSBeeb on the right-hand side. So you've kind of got this WYSIWYG editor thing, and that was just something I knocked out in an afternoon, because the obvious thing of like, well, you run this one website with all the code thing, and you run this one thing with all the emulator thing. Is there one way you can put them together? It's totally unsupported and was just a hack. I don't even know how it's still up, to be honest. I don't know how much time I've got. I can keep talking forever, so I'm totally banking on somebody who's running this to interrupt me.
Yeah. If there's a moment, I've got a Code Explorer statement for Matt that you might find interesting.
Okay.
Other members on the forum will have heard this. ARM GCC, the GCC ARM backend will generate undefined instructions in the ARM data stream. If you didn't know that.
Sorry, I have to unmute myself, don't I? I didn't know that, actually, and that could be an artifact of the fact that we're not necessarily in step with the GNU Tools version and the compiler. Like, there are there's 600 odd compilers now on Compiler Explorer, and it's a reason that I'm going grey is mainly trying to keep those all up and running and mostly built from source. So I'm a sort of part-time compiler engineer, it would seem, but not like in a good way. So yeah, I don't know. It's almost certainly a mismatch between the GNU Tools that it's using and that. But if you send me a link or
yeah, as far as I can see, I was doing some bare metal with connecting my Pi to the Beeb, and I cheat to make performance good. I move the vectors away from 0 in memory, and so then the C compiler I was deliberately writing to 0, and that turns out
undefined. Yeah,
undefined.
So the compiler's allowed to do whatever it likes with that. If it detects that you're doing it, it's like, I can assume this can't happen. Therefore, I can throw your entire program in the bin and replace it with a picture of a herring, and that's fine.
I would have liked a warning.
Right. I mean, there's the famous Linux kernel bug, which the same thing happened. It's like, hey, but we check it afterwards. We dereference it, or we get an address of it here, and then we check it, and then it's like, no, it's too late. You were doing something undefined. The compiler's allowed to assume, which is a pain in the bum. But when you take it away, the compiler starts emitting dumb code all over the shop, which is unfortunate. It's kind of a double-edged sword. But yeah, that's really interesting. I mean, it's a really fascinating thought that's a valid thing to do. I'm fairly sure that you're allowed to assume that the null pointer is not 0. It's just that there exists something which is null that is invalid to write to. Oh man, I wish I might be on a Slack. I can ask someone, but I wonder if you can tell GCC, like, hey, my null, it lives over here. It's not 0. It's hex 8000 or something.
Yeah, I couldn't find a way. So in the end, I wasted an extra cycle in my assembler that deals with the other half of the code in the interrupt routine.
It's sad. That's sad when you have to do that, but it's also not totally surprising. I mean, it's lovely that you can write this in a moderately sane language and not in pure assembly anyway, the kind of stuff I'm sure you're doing if you're worrying about that kind of thing.
Yes. Yeah. But yes, your Compiler Explorer is very useful.
Oh, I'm glad. Thank you.
And JSBeeb has been very useful.
It's weird that you're being able to use them together, but pleasing, very pleasing.
Yes.